Hello, here's a quick review over solving equations and inequalities. This information, remember, can also be found in your notes if you have them. If not, you can always log on to your Canvas account, and the notes are also posted in Module 5. In Module 5, we learned that an equation and an inequality are very similar. Their biggest difference is that an equation will have only one solution and an inequality will have many solutions. They are both solved the exact same way, but are represented differently. So with an equation, you will have an equal sign, and with an inequality, it will be represented with an inequality symbol. That could be a greater than symbol. It could be a greater than or equal to symbol, less than, or equal to symbol. So at the beginning of this unit, one of the things that we discussed was being able to use algebra tiles to describe an equation model. So just a quick review on how that's done. Remember, the long rectangle shapes represent our variable, and the small shapes represents our number or our constant in our problem. So if I was to read this model, or write the equation that matches this model, I would write an X for the one to represent the one rectangle model. And on this side, I have also two positives, my equal sign, and then on this side, I have 6. So X plus 2 equals 6. Here's another example, which would be read 4X equals 4. Here's another example, negative 4X equals 16. So here are the notes from earlier in this module of solving equations. Here's an example of me solving one. Again, I'm going to isolate the variable by 0 pairing out the 46. And then I'm left with D equals 58. Inequalities will be solved the same way. I'm going to add negative 17 to both sides. Isolate my variable, bringing down my inequality symbol, and I'm left with 3. X is greater than 3. So multiplying and dividing equations is where some of us kind of were a little confused. So I want to go over that again, just looking over the notes. Keep in mind, a big thing to remember here is that multiplying by the reciprocal is the same as dividing. So for example, if I multiply by 1/6, it is actually the same as dividing by 6. And the reason why this is so important to understand is because we will not always have whole numbers that we're working with in our equations. They will sometimes be decimals. So if we understand now that those two things mean the same thing, it'll make it easier on us later on. So if you look at the examples that were already completed, you can see that 8x equals 32. That one way we could do that is to divide by 8. We're isolating the variable by doing the opposite operation, the inverse operation. Okay, but we could also take this same problem and actually go ahead and represent it as a fraction by putting 8 over 1 and multiplying by 1/8 to isolate the variable, as you can see in this second example. So remember, in this case, we talked a lot about the different ways we can represent a division problem and a fraction. Division problems are fractions. So we want to make sure that we understand that those two things represent the same thing. I'm going to work a few of these problems out just to kind of give you a quick refresher over some of the options that you have on these. So again, you have these in your package of notes for Module 5, but also they will be attached in the completed copy of the notes will also be attached inside of Canvas if you need a little bit more refresher. But again, remember, inequalities are going to be solved the same way. We just really need to remember that that fractions can be written as 8, it could be written as x over 8, it could be written as 1x over 8. All these things mean the same thing. When we solve equations and inequalities, they will be solved the exact same way. Again, the only difference will be with our solutions. My equations will have only one solution, and your inequalities will have multiple solutions. So to solve an equation, we need to remember that we need to isolate the variable. In order to isolate the variable, we need to remember what it means to create zero pairs. Zero pairs are created when you have an equal amount of positives as you do negatives, which eventually will actually cancel each other out to give you a value of 0. Okay, so now it's your turn. Solve the equation below. So b is equal to negative 13. Solve the equation below. So n is equal to 18. Keep in mind, you have to remember and follow your integer operation rules as well. Okay, here's another one to try with multiplication and division. So I'm going to add my 1 with my variable just to have it there. To isolate my variable, I notice there's an 8 in the denominator on the same side as my variable, so I'm going to put the 8 in the numerator. Multiply by the reciprocal means I'm flipping it, multiplying by the inverse. So I'm going to do the same thing on the other side of my equation. And then I'm going to just multiply like we would a regular fraction. Go ahead and put my 1 underneath there to help myself out. 18 times negative 6 will give me negative 108 over 1 is equal to, in this case, it would be 18b over 18. We know that when the numerator and denominator is the same, it is equal to 1. So that's going to get 1b over there by itself. And then when the denominator is a 1, whatever is in the numerator is your answer, which is our whole number. So b is equal to negative 108. Same process. This means 10 times n equals 40. So right now that actually says that the 10 is in the numerator position. So the reciprocal of 10 over 1 would be 1 over 10. Okay, again, that will give me the 10n over 10. And of course, that leaves me with 1. Bring down my equal sign. This would give me 40 over 10. So you can see in the end, we're still dividing. But again, this is just getting us ready and prepared for when it turns into fractions. We immediately know what to do. We're just flipping it over because we're multiplying by the reciprocal. So this is really the same as 40 divided by 10. And 40 divided by 10 would give me 4.